bit about the company we founded, the reason why we founded the company, the challenges we observed in the market, and then a bit of the kind of opportunities we saw when kind of addressing them with AI. I want to touch a bit, I mean, I like to talk a lot about tech, and AI, but I tried to keep it a bit as a minimum. I want to give you a bit of an introduction to kind of the recent trends of AI, what we are working on, and how we think there might be a good fit for specific AI trends and technologies to address those markets, challenges we observed in the market. But then I also want to touch briefly upon the challenges we observe in bringing them actually to the user and the adoption of those technologies. So I thought that's what we talk about. Before I start, maybe just a very brief introduction of what we are doing with Innex. So we are developing a software which is specifically trying to help managing regulations and compliances in a very specific use case, and that is for non-clinical staff members in a hospital. So for example, you've got lots of facility managers, engineers who are responsible for fire safety, ventilation, medical gas pipelines, and all of these kind of infrastructure tasks. And we found that usually their workflow is quite complex, and because it's highly regulated, they have to deal a lot with regulations and compliances and national guidances and how they conduct their work. And we thought there would be a good opportunity to use AI to kind of augment their kind of relatively complex workflows and help them to do these tasks better, quicker, more efficient, and all of that. So maybe just in a nutshell, on the left-hand side, kind of the challenges we observed with specifically in the NHS and those service operations. So for those engineers in the kind of healthcare domain, you've got relatively complex operations in the way they're kind of maintaining the infrastructure. But also got lots of inefficiencies in those processes we can observe. So departments working in isolation, fragmented workflows, and I think lots of these kind of characteristics are probably applicable to quite a lot of large organizations. Not speaking about the NHS here as well. They've also got workforce management and skills gaps. So again, if they're understaffed, they need to recruit from different domains, need to upskill the workers, engineers to a sufficient level to comply with those regulations as well. They've also got cost management and budget constraints, as I think everybody does kind of, and there's a lot of siloed working going on. So what we try to do is we try to go and understand their kind of workflows and kind of ways of working, and try to figure out how we can use AI from various technologies to help them do their work. And we did a bit of research and found out that one of the commonalities between those kind of engineers and people who have to deal with a lot of regulations and compliance is that depending on their kind of job level, they spend up to 11 hours a week just looking for the information in those compliance regulations databases, for example. So we thought, oh, that's a great way to help them as a first step and use AI to do that. So we are using kind of technologies such as language models, retrieval augmented generation, agents, and all these kind of new fancy AI things to ideally streamline the process. So rather than going to the browser, trying to find the most recent regulations, maybe ending up in an old version because it hasn't been updated on the database you're looking for, we build a chatbot, like ChatGPT, specifically do that data and kind of streamline that process. And we found that we can save them up to 35% of the time. It's quite an efficient game. So this is just as a bit of a nutshell of what we're doing. Maybe just go a bit into the background and into what we found in the market, and in this specifically use case, a case study, what the challenges are and what the potential impact is. So I'm trying to replicate this because this is not my 4 years of research. This is my co-founder's 4 years of research within knowledge sharing in estates and facilities within the NHS, all these kind of large organizations. And when it comes to kind of knowledge sharing, one thing which sometimes is quite difficult is how do you ensure that kind of vertical and horizontal information flow goes along? And if you imagine in the UK, you've got lots of different hospitals. You've got here in Cambridge, we have Edinburgh, one of the very large teaching hospitals, but you've also got community trust, mental health hospitals. So all of them are very different context, and all of them are very different requirements and compliances and regulations. So kind of making sure that best practices are shared across them on the horizontal line can be quite tricky. And similarly, on the vertical flow, you've got national guidance being written, updated every 5, 6, 7 years, which is questionable itself, but then only published, right? So there's only a kind of one-way information flow. There's no really feedback loop into trying to understand what's going on the front line and kind of having this kind of up and down information flow. So it's quite ineffective. Again, complicates knowledge sharing as well. You've got fragmented workflows and siloed systems, as I mentioned before. You've got kind of departments working in isolation and also maybe in different hospitals relatively complex tasks and dependencies on other departments when you kind of do your compliance checks and so on. And as I mentioned, a lot of kind of outdated and inaccessible information sometimes. When, for example, we had a huge issue in the UK with crumbling concrete in the last couple of years. And maybe some hospital or some trust has solved that already, but who knows, right? I need to kind of figure it out myself. So quite inefficient. And the kind of impact we saw with that was, I can use this, no. Kind of missed opportunities on kind of replicating and adapting best practices, slow coordination in emergencies like COVID, time-consuming audits, and the kind of, again, outdated standard because you don't know what's going on the front line, and then you just update regulations because you think you might as well, rather than actually responding to what has been happening. So then we came along with AI, and just I want to give a little bit of a broader introduction before I go into the deep recent trends and to how we think AI could help kind of address those individual challenges. And the one thing we are really focusing on are large language models at the bottom, which are positioned kind of within generative AI, deep learning, and the kind of very broader machine learning elements, which we've known for years. And maybe the one specific characteristic of large language models is trained on huge amounts of data and trained to kind of predict the most likely next word. So it kind of enables you to have a conversation, as you all know, with ChatGPT, for example. But they also have a problem in that they can be quite prone to hallucination and making up new things. So a lot of the research in the kind of AI domain over the last couple of months and years has been on how do we make them more applicable and how do we reduce the error rate in using them? So how is the answer more relevant? And this can be a lot, but the one thing I want to talk about today a bit is agentic AI or different agents. So a recent research stream is looking at how can you design a system of lots of different large language models, which are very specifically trained or instructed to an individual task, and then connect them to each other so that the output of one, the first task, triggers the second LLM and the third LLM and so on, and you can kind of design an agent and replicate a workflow. And I just want to mention some of the kind of tools these kind of agents can draw upon. So one of the advantages of those agents is that they, or these language models in the way they are designed, is that they can draw upon different tools in order to make your answer more relevant. For example, one thing I talked about, briefly mentioned at the beginning, retrieval augmented generation is a way of extracting, let's say, you're looking through all of your, I'll try to make it relevant for research, all of your results from the systematic literature review, and you're asking a question, has anybody ever asked this research question? It will go through the, 300 results of your systematic literature review and try to find the research question and whether it has been asked or not, and use that in order to answer your question. So it kind of grounds the answer in data. And then there's retrieval interleaved generation, which is kind of a way of kind of connecting your chatbot to real-time information tools, such as the data, the weather, right? So there is an answer, and it kind of tells you what the weather is today, which is not in the kind of, we talked about it before, historically trained data set, right? That didn't show what the weather is at Cambridge, end of September 2024, but it's a way of doing that. And then more recently, chain of thought reasoning. So how can you maybe use a language model which kind of step by step gives you an answer rather than trying to jump to the conclusion right away? So all of these can make agentic AI systems quite powerful in completing individual tasks. And these are the ways or the application areas where we are using them for the individual challenges we've talked about before. Very simple at the left-hand side, question answering. So if you have a question to your compliance document or about your regulations, for example, what is the window restrictor in a mental health clinic so that nobody jumps out of the window, for example, and you need to comply with that specific measurement, then rather than looking through the documents, which might be 80, 90 pages long, you can do a Q&A session with your chatbot, for example. But it can also go a step further, content creation, which is becoming quite popular, policy writing, regulations writing, reviewing documents, reviewing policies, and so on, trying to check whether they are compliant with different regulations and so on. And then analytics, a bit more advanced of how you can make sense of kind of tabular data, Excel sheets, and so on, in order to get the right results. We did a study recently with a hospital in the north about their kind of cleaning audits, figuring out what are the most common failure types. Is it limescale, dusting, and so on, and how can they address it? all ways of using these kind of agentic AI systems in order to kind of bring it to the real world practice. So it all sounds nice and shiny. Cost reduction, faster decision making, improved efficiency. But sadly, you can't go to the hospital and say, use it, and you'll get it immediately. So these are kind of some of, based on our kind of experience over the last years, barriers of adoption maybe, or barriers of kind of value creation for those agentic AI systems, which might seem to be obvious and kind of the same thing with every new technology, but I thought it's still worth highlighting some of them. One of them is, for example, trust issues in AI outcomes. So especially if you deal with regulations and compliance data, and if you tell them the window restrictor is X, Y, and Z, like, do they believe you? Do they now kind of trust you to be compliant with the specific national regulations? So one thing we had to work a lot around is not only trying to give them the right answer, but actually telling them where the answer is from. So lots of links and references and so on. Managing expectations of performance. So especially if you're not very familiar with AI, you might have the expectations that it's all great and new and it can do all the work, but realistically it will only get you to a certain point. You still need to review it and you still need to check it, and kind of managing these expectations kind of increases a lot the adoption of the AI technology. I thought a very interesting one of kind of our background of customer experience management is a bit the interface and usability design. So in what way do you present the information or the facts to the user so they find them useful? In what way do you personalize them based on their role? Something we need to work on. Then I think user behavior change, organizational change of integrating new AI technologies, integrating them into your individual workflow can sometimes be a bit challenging. And then actually communicating value, because a lot of our kind of proven benefits are non-cash releasing benefits. So you just gain efficiency, do things quicker. But you can't really necessarily, that doesn't mean you have more money in the pocket immediately. So the kind of ROI calculation becomes quite tricky at times. So these are kind of the challenges we face at the moment to get to the top of improved efficiency and cost reduction, really. Now that could be quite interesting, a thing I've been thinking about over the last couple of weeks, of how maybe some characteristics of agentic AI systems compared to kind of generic language model applications can help to kind of overcome some of those challenges to increase adoption of AI. And just on the left-hand side, some kind of characteristics of those tasks and systems I've described. They can autonomously kind of carry out individual tasks, those little LLMs, which you tell them, you are now responsible only for reviewing a compliance document, for example. But you can then also, if you have this system of different LLMs, quite deliberately design where you need and want to have a human input. So which tasks should be carried out automatically, which shouldn't, and then integrate them together in a system to kind of keep the control with maybe critical decisions where you don't trust the AI to do it, with the human being who then has to kind of interact with the AI system. Then we found that performance-wise, those kind of language model agents perform significantly better if you have a set task description and boundary of what they should do, rather than giving them open-ended questions. And then the systems can be quite scalable and adaptable. So with these characteristics, we found that you can address quite a lot of those trust issues of doing stepwise automation, rather than trying to kind of throw AI at a big complex workflow and say, let's automate it, but actually trying to identify and map this kind of step-by-step approach. And then also you can manage the expectation management by start with the mundane task with little complexity first, try to get some human input and automate and kind of teach the model to kind of increase their performance in individual tasks, so to say. And then also it helps with the user behavior, because the way those systems can be designed, you can kind of hack them around your already existing workflow rather than requiring a whole overhaul of the system with a new approach. So that's our thought, not proven yet, but I think it could work pretty well, actually. And maybe I'll just end with an example. On the left-hand side, please don't take a picture of that. A process diagram of a compliance written process for, I think, a ventilation compliance document. Quite a complex workflow, lots of different steps involved, lots of different collaborations involved. You have lots of people having to giving input, having to giving review, having to check off things and all of these bits. And we're trying to kind of mimic that with all of the things we've talked about, like agents, LLMs, and so on. but also human input in order to kind of identify where do you need this kind of critical review and so on to kind of streamline this process, because that can often take up to a couple of months. And we've got this on the right-hand side where we designed a system, and you can see a bit on the left-hand side what is the AI doing, on the right-hand side where do you require the kind of human input to get to a kind of good first draft in a couple of hours. And for example, here the workflow is that the human starts and gives a table of contents to the system. Okay, these are the things I kind of want to write in my compliance document. Then what the kind of agent does, there are various agents involved. There's one which is only responsible for writing a first draft based on previously deemed good examples. Then writes the first draft, sends it to a second agent, which you could call a reviewer. It reviews it, searches the database for kind of claims and the appropriate references. So if you have a claim of, let's say, the ventilation policy, the ventilation system should be inspected every year, then it would extract that claim, go out, search the database, and it would actually say, well, the regulations in the NHS say it's only required to do that every 3 years. So then it kind of comes back with a kind of answer to your claim. And then there's the third rewriting agent, which kind of integrates the references and the claims, the answers to the claims into the document and sends that back. But the human then can still go back and say, well, actually, I'm not happy with this because you haven't considered this specific requirement, this specific context, and so on. So this is where it kind of provides instructions for individual sections, requesting rewrites, and then can compare against other documents to get to a kind of time-saving, compliance-based practice and evidence-based policy writing tool. Just as one more detailed example of how we kind of try to use agentic AI to kind of augment those relatively complex workflows and how that can help. I'll leave it there, and if you have any questions, let me know.